All right, so last time we talked about this chart and where all the groups were on the NMR. So if you have those notes, take those notes out. But we talked about that alcohols and amines and carboxylic acids have those peaks around 3,500 in that range. Alcohols are kind of broad. The carboxylic acids are even broader than that. Carbons and hydrogens, we said at 3,000. To the left is the aromatics, and to the right are aliphatics. We talked about aldehyde. The aldehyde peaks show up as the fangs around around 27, 2,800, around there. And then triple bonds show up in this region. If it was a terminal triple bond, however, we had that hydrogen on the terminal triple bond show up also in this region. So if you see a triple bond, also look in this region. That will tell you if you have a terminal triple bond. And then we just talked about carbonyl show up around 1,700. And anything lower than that, we just basically ignore. We didn't really talk about C double bond N's and C double bond C's. So that's what we talked about last time. So what I want to do is just look at some IRs now and just kind of use this information to kind of analyze IRs. All right? And just to kind of show you the types of problems that you can see. So I found these problems online. I have a whole bunch too. I'll show you online that you guys are able to practice. But we'll kind of do a bunch of practice right now. All right, so this is kind of the type of thing you'll see. You'll usually have a formula, and you have an IR, and then a bunch of structures. This is one way of doing it, okay? So by looking at this IR, why don't you guys tell me what functional groups you see based off of what we talked about? And if you guys want to go off your mics, if you want to go on your mic, I'm totally fine with that. We have 8 people in here, so I don't feel like people will be like talking over each other. So Luke says an OH peak. Okay, so he sees an alcohol. Yeah, immediately, very characteristic alcohol. Amy says aliphatic. Yep, very good, Amy. Definitely aliphatic. So the alcohol peak is this big round peak right there is your aliphatic. I'm sorry, your alcohol peak. And then aliphatic, here's 3,000. You can see just to the right of 3,000. I mean, you can draw that line right up there. So aliphatic and an alcohol. That's pretty much it. This is, let's see, 2,000. That might be a little too low. Let's see, 2019, 18. That's about 1,800. That could be a carbonyl. All this stuff we basically are going to ignore. Okay, but yeah, I mean, possibly I can have a carbonyl. However, I really can't have a carbonyl. If it's kind of, because of the fact I only have one oxygen, I have to have this alcohol here. These peaks, I think I told you, sometimes it could be water. So if you see little extra peaks, it's water. But like based on the structures here, what possible structure can it be? So which structure is it? A, B, C, D, or E? All right, so Luke says the ring, E. Ashley says E. Yep, exactly. Right, it could be E. It has to be E. Alcohol and aliphatic. So why is it not D? The reason it's not D is because D does not match this formula. Okay, I believe this is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so it can't be D. So here's the thing. If I did not give you the formula, then you would have no idea if it's D or E. Okay? So if I did not give you the formula and said, which one of these is it, you would say it's either D or E. More information would have to be given. Okay, just remember, IR just gives you functional groups. It doesn't tell you anything about the structure. NMR will tell you which of these structures it is. It'll tell you if you have a cyclical ring, or it will tell you if it's a straight chain or something like that. Okay, NMR definitely is much more powerful. Like I said, I think it's important that you guys get it, so I'm going to make the videos on it. But as far as, since I have this formula, it has to be E, knowing that we have a carbonyl and it's aliphatic. Okay, and that's basically IR, all right? Here's another one. I'm going to give you guys a few minutes to kind of see if you can figure out what the molecule is. All right, so I'll put it. Okay, so you definitely have aliphatics. All right, so there's no aromatic. And then this peak right here is about 17, a little above 1,700. So it's a pretty big peak. Carbonyl peaks usually are very large like that. You have this big long peak at 1700. Plus, you have an oxygen. So I know it can't be an alcohol, right? I have an oxygen in my formula, so it could be an alcohol, but I do not have an alcohol peak, so it can't be the alcohol. So it can't be A or E. Okay, and then you have a carbonyl peak, so it's either C or D. B doesn't have a carbonyl. So again, if I did not have the formula, it'd be either C or D, but since I do have a formula, it has to be D. That's the only one that fits. Okay? Make sense? All right. Let's do another one. Oh, it looks like it's the... No, it's a different one. All right? When you're ready, if you want to, why don't you put in which one you think it is, A, B, C, D, or E. All right? This way I can get ideas. Stuff. You guys are getting it. Okay, so, all right, Luke, you can't put more than one answer, man. You covering all your bases? Yeah, it's D. No, it's C. No, I think it's A, B, or E. Oh, okay. You guys only get one choice. Okay, so let's talk about why it can't be D. I mean, even without looking at the formula. So D, I can understand. So when you said D, I originally was looking at it thinking aldehyde because the peaks right here. So remember that the fangs, the peaks have to be exactly the same size, but you also are looking for a carbonyl. And notice we do not have a carbonyl here. It would be around here, around the 1700. And I don't have a carbonyl peak there. I would have this huge peak, like in the one here. See how big that peak is? That's what I would have also in the 1700. Remember, all these peaks I ignore. All right? So because I don't have a carbonyl peak, it can't be D. Even if I did not even have the formula. All right? Plus 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that only has 12 hydrogens. But even if you didn't do that, you don't have a carbonyl peak. So it can't be D. It can't be B or A because I don't have that OH peak. All right? So that means the only other possibility is it C or is it E? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 4, 6, 8. 10, 12, 14, where this has 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so it has to be C. Okay, so that makes sense. So everyone who put D, I can see why you did it, because it looks possibly, but again, the fangs have to be the same size. These two little peaks are too small. If you've got this junk up here and the peaks are about the same size, that's junk. In order to have fangs here, you have to see two very obvious choices. If you kind of have to squint your eyes and say, well, is that maybe the fangs? Then it's probably not the fangs. Okay? So I'll make sure that you guys understand about the aldehyde. All right, here is I think it's the last one of these, yeah. So here's another one. So once you guys... It smells like vomit. Oh yeah, I know exactly what that is now. It's Taco Bell. Must be an IR for the refried beans in Taco Bell. Okay, once you guys go ahead and let me know which one you guys think it is. So this one's B. This is carboxylic acid. Look how incredibly broad that peak is. It doesn't even matter about aliphatics because you can't really see them anymore because they're completely buried underneath it. So you see this, that's carboxylic acid, and B is the only acid here. And you also have the carbonyl peak, but so that's pretty much it. Okay? Make sense? You guys like my Taco Bell joke? I didn't get any LOLs or anything off of that. I thought that was hilarious. I thought for sure you guys would be like, oh, I totally agree. I don't know, I guess as a college student, I used to eat Taco Bell all the time. It used to be the late night Taco Hell, exactly. It used to be the late night food. Yeah. Oh, Oh, Kelly, I ate Taco Bell maybe 2 or 3 years ago. I haven't eaten it in years. I had such stomach issues. I mean, I get my age, you can't handle that stuff anymore. I zoned out and then just heard you talking about vomit. I was very confused. I'll remember that. If I have to do these remote classes again, every now and then I'll just throw in the word vomit or something in there. So as you see, as the carbon vomits all over the place, and then the oxygen attacks as the nucleophile comes in. Just to keep everybody awake. I'm telling you, I'm learning so much from doing this. All right. Okay, so here we go. Here's a problem. This might be hard to see. So I have a handout. If you go on our website, if you go to the IR, right here, IR NMR practice, I have this IR set. I posted this just right before class. All right, and if you pull it up, it's right here. There's set 1. There's a whole bunch of IR practice problems. So I thought what we do is go through maybe a few of them, and then you guys can do it on your own. Or what we'll probably do is I'll have you do them, and then we'll stop, and then we'll go over them. So I just wanted to go over the first one. So if you want to download those, I'll give you a chance to download them. So I'll tell you what, I'll give you about a few minutes to go find it and download it. However, this first set I actually put here so that we can go over it, so I can show you. All right, so I want to give you guys a few minutes, download it, go online, download it, and then we'll start back up. All right, let's start this. Okay, so this is the first problem. The first problem, you've got 3 IRs on the first page, and then on the second page you have this IR, and then you have these 4 possible answers. Okay, so what you're supposed to do is match the IR with one of the structures. Okay, so what do you say I give you guys a few minutes to do that, or would you like to just do them all together? Or maybe do one together, and then you guys are able to do the other ones. What do you guys want to do? So either you do it, say us if you just want to do it, say we for all of us, or just say one if you want me just to go over one of them. I'm still downloading. Okay, that's fine. All right, Luke says us. Okay, so yeah, so why don't you download it, Kelly, and then I'll give you guys about 5 minutes in order to do it, okay? All right, I'll be back. Actually, I just read what Kelly said, and she said we. So why don't I go over the first one, since there's a mix of people, and then you guys can go off and do the other 3. So for analyzing the first one, I first noticed these 2 peaks right here. Very 2 sharp peaks right at this 35 area. So that is characteristic of an NH2. Remember we said that if you have 2 peaks, usually it implies 2 hydrogens. All right, and it's hard to see these, but each of these numbers is at the thousand. So this is 4,000, this is 3,000, this is 2,000, and this is 1,000. And then at 3,000, it's kind of hard to tell, but it looks like I have peaks just to the left of 3,000. If you drop your line of 3,000, looks like everything is just to the left of 3,000. So that would imply an aromatic ring. All right. And then, remember, at 1,700 is our last area, which is, let's see, 19, 18, 17, which is around right here. And I don't see anything here. All this stuff, remember, ignore. These peaks are too small to actually analyze. They have to be roughly around the same size. Not always, but sometimes they do. So this basically says I have an aromatic and I have an amine. So that would fit that molecule right there. Okay? So that's basically how you do this. You just kind of look at the functional groups. Remember, we're looking at 17,000 to the left. Really not too much information is given. Again, it's just giving you functional groups. Okay? Okay, so hopefully that helps, and I'll let you guys do the rest of them. All right, so let's go over these. All right, so the next one, here's 3,000. right there. And everything is just to the right of 3000, so this is all aliphatic. This stuff looks like junk to me, but if you might be thinking, well, maybe it's aldehyde, maybe it looks like here's one of the things, here's the other, it's kind of too far away. But if you're kind of squinting at it, not too sure, what you do is you look for the carbonyl. If you do think it's an aldehyde, and you would expect to see a carbonyl around here, and I don't. So I know it can't be things, it's probably just like junk or something. So this basically just says I have aliphatic on a molecule. So that would represent this molecule right there. Okay. Next one should be pretty simple. That's a carboxylic acid. Look at how broad it starts here, and then it doesn't end until right here. The whole big thing. All this other stuff, like I said, doesn't really matter at that point because things are buried underneath it, and everything, it kind of gets stretched out a little bit. So none of these peaks really matter at this point. If you have a carboxylic acid, nothing else matters. So that basically is it. So that would be a carboxylic acid, and then by default, obviously this one. This is really rare. You rarely see these peaks so little, but in this one you just happen to. But if you draw that straight line, you'll kind of see that you have peaks the left and the right of that 3000 area. Plus you have a carbonyl right there at about 1700, so that would represent that ketone right there. Okay? Makes sense? Any questions? All right, I thought what we would do is we would just kind of do this. Let's do it for set 2 as well. So I'll copy and paste them into here, and then I'll give you guys a chance to work on it, and then we can go over it again. All right, I feel like this is kind of a good way to do it, just to kind of give everybody a chance to work on them. So if you downloaded it, once you guys go ahead and just do it, you guys, a few of you might have already gone ahead, which is fine, but I'll give everybody a chance to kind of do it. Oh, that's not what I wanted. Good. All right, there you go. And let me know when you. All right, so we'll start with this one right here. Here's 3000 right there, and it looks like things are just to the right of 3000, but it also looks like we possibly have things right there. All right, see how these two are separated and they're just hanging out there? Plus we have a carbonyl peak. All right, so aliphatic with fangs, so implying an aldehyde in the carbonyl, so that would be for this molecule right there. All right. Next one, we also looks like we have aliphatic and aromatic and aliphatic, and it definitely looks like I have a nitrogen. And let's see, do I have a carbonyl? Yeah, it looks like I possibly have a carbonyl. Let's see, 18, 17. It's pretty close. That peak right there looks pretty close of being a carbonyl. All right, so that one's a little tough because that carbonyl is a little lower than usual. But it's really the only thing that, so it'll match that one. I mean, if I did not have that molecule, this would be a little tough to analyze. Okay, you have to be, again, you kind of given, you would have to be given more information. Alcohol, boom, don't have to go any further. There you go, alcohol. So alcohol is just so characteristic, obvious as to what it is. Come on. All right. And then obviously the last one's going to be anhydride, but here's 3000 right here. Looks like these peaks are just to the left of 3000, so that would mean just aromatic. All right, and I definitely have a carbonyl peak. This is close to 1800. I got 17 and 18. So I definitely have a carbonyl peak there. So that would imply that one right there. Okay. Good. Questions? You guys getting it? And this is pretty much IR. I mean, honestly, everything I've taught you is all that I know. Good, Kelly. Everything I taught you is everything I know about IR. It's not too much. Things haven't changed much in the past several years with IR. Let's see, this one is another one. So I'll put this up and then let you guys work on it. Also, a lot of people usually like these chapters because it's a break from reactions and synthesis. Well, at this point, we're pretty much done with reactions and synthesis. So it's just now analyzing it. Like, okay, we know how to synthesize stuff. Well, how do we know we actually made it? How do we know I actually have that compound? Let's see. Can you guys see that? Yeah, you guys can. My camera can't. Okay, so this time I think we have 3 IRs, and it matches one of these. So put the corresponding letter with it. Let me just double check, make sure. I think that was it. Oh no, wait a minute. There are 2 more, aren't there? That's page 5. That's page 6. Yeah, page 7. One more. Just one more? One more. Okay. I don't know where we're going to put this. I guess we'll put it down here. Let's see if we can do this now. So you guys see everything? Yeah. Yeah, use the scale above it. I know the scale on this one is chopped off, but I think the scale matches up perfectly. So like 3,000 here. There's also 3,000 right under here. Here's 2,000. Here's 1,500, 1,600, 1,700, 1,800, 1,900. Okay? You guys see everything? I think there's just 4. Yeah, that's the next one. Okay. That's page 7. That's page 6. Page 5. All right, perfect. We got it. We made it work. All right. Let me know when you're done. Like from this decade. I mean, like, are you talking about like String Cheese Incident, like those types of bands? Because they've been around for a long time. But okay, anyways, let's go. Okay, so this one, let's see, we have definitely looks like aliphatic and aromatic. So we definitely have aromatic here, and we have aliphatic here. 15, 16, 17, possibly carbonyl. This is kind of, a few of these are a little bit harder to actually analyze because I think it's kind of that's kind of the point of these, just to kind of show you that it doesn't have to be as straightforward and cut and dry. But it does definitely look like you definitely possibly have a carbonyl. It's right on the border there, 15, 16. That's about 1650. It's getting a little low, but definitely most looks like a carbonyl. But the fact I give you options, it has to be a carbonyl. Because it's the only molecule that has both aromatic and aliphatic. All right, so this would be for structure B. This is kind of the one where it's kind of a little bit of a head scratcher. You might think you have an amine here possibly, or an alcohol. But actually, if you keep analyzing it, you'll see that you've got aliphatics here. And then you definitely have a aldehyde. Say that peak right there is just kind of a lip that's approximately the same size. So you have the fangs, plus you have a carbonyl that is sticking out there. Obviously, don't have an amine as an option, so it can't be an amine. So possibly an alcohol, but it's actually water. That peak right there is actually the peak for water. The fact that I have an aldehyde and aliphatic means it has to be compound F. Plus, if you look at this IR, I definitely have an alcohol peak here. That, without a doubt, is an alcohol. So it's something like this. It's not clear and straightforward, but it gives you hints. And that's the thing about aldehydes is that I'm sorry, aldehydes. About IRs is that it's not always as perfect as you would like it to be. Okay, so this one would be for F. All right, and then this one, aliphatic carbonyl. You have a bunch of junk up here. I cut it off. You can't see, but that's pretty much water up there. So that would be for A. This would be compound A, and then this would be your alcohol. This would be E. All right. Questions on that one? Okay, so look at the first one. So the formula kind of helps you along, especially if there's peaks here that are a little confusing. All right, like if you look at this peak, all right, it looks like we have peaks on the left and the right of 3000, but I can't have aromatic. And I know I can't have an aromatic because I only have 2 carbons in my formula. All right, so here's another example where don't rely too much on those numbers. Most of the time you can, but if I'm giving you other information, I would not give you this if I did not give you a formula or other information. So you kind of have to use the formula and the IR to kind of help you with the structure of it. And then you obviously have a carbonyl peak, gigantic carbonyl peak. You might think maybe I have a nitrogen, or an amine, but I don't have a nitrogen in my formula. So based off of this, I have aliphatics and I have a carbonyl. Okay, so if you take the formula and just kind of arrange it around, the only possible structure that you can get that would fit that would be an acid chloride that has a hydrogen, be 2 hydrogens and a chlorine on it. All right, so that would be the only possibility. If you put the aldehyde, let's say that you did this instead, if you switch the chlorine and the hydrogen, all right, why would that not work? Well, that would mean I would have an aldehyde and I would have to have fangs right there, or those 2 big peaks at 27 to 2800. Okay, so if I did have that, then this would be the structure. But since I did not have that, I don't have those fangs there, so it has to be this structure over here. Does that make sense? Hope you guys were able to get that. All right, also, you kind of have to use your knowledge a little bit of writing formulas and making sure that, you know, everything has the correct number of bonds. All right, now the one down here, again, if you look at the formula, okay, and if you start looking at the peaks, all right, it looks like maybe I have amine peaks right here. Okay, possibly I have amine peaks. I have aliphatic peaks, that's for sure. And then I have this huge peak right here at 2300. All right, this without a doubt is a peak. These little peaks here, maybe that's amine peaks, maybe that's just water. The fact that I have a huge triple bond, okay, there are 2 things that this could imply. Okay, 2 things that this is able to actually imply. So there are more than one possible answer on this one because of the fact that maybe I have an amine. Oh my goodness, sorry about that. Someone slammed the door and something fell off. Hope that didn't scare you. It certainly scared me. All right, so what was I saying here? Oh, yes. So there are actually 2 possible structures. Just because of the fact I have this could be garbage or it could actually be a peak. Could be that I have a cyanide. So I have CH3, CH2, and a nitrile. Okay, so this peak here would be, or that group there would be at 2300, and then here's my aliphatics. However, it could be that I do have an amine, and then this peak right here could be a terminal hydrogen on a triple bond. So this can also work as well. And you can have, let's see, it be 3 carbons. So CH2 with an NH3 hanging off of it right there. That's right, NH2. Okay, so both of these are acceptable. Most likely it's this one right here, just because it has all of the peaks that'll match up. We have a triple bond, we have an aliphatic, we kind of have this small little peak. Remember, the peak here would be for the terminal triple bond, and then we obviously have the 2 NH2 peaks. So does that make sense? So in this case, I would maybe accept both because these peaks are small. But if you put this one would probably be the most correct based off of the peaks we have. But you can easily argue, well, that could be water, it could be junk. You see what you guys are saying. Cool, I did the terminal. Good, that's perfect. Yeah, that is the actual structure. But this could be argued as well. So again, this kind of showing you IR, it's not the end-all be-all. In the NMR, you would be able to tell if you had an ethyl group or if you just had a CH2 group and a terminal hydrogen, stuff like that. So the NMR would give you more information about it. Again, this is just giving you some of the functional groups. Okay. Okay, so once you go ahead and that's pretty much the time for the day, but once you go ahead and do 3, 4, 5, and 6, I don't know if I have these answers posted. Let me see. I don't think I do, but I can post them on there. Yeah, I don't think I post them because I think this is something that we do in class, and then I